Hello my dear students, here's again your computer Wunsam, and today I will show you what you can do with so-called loops. Loops are an interesting thing to program because loops have the possibility to run and run and run until a specific condition is finished, a condition which states that the loop shouldn't be running anymore. But let's start it by simply creating a simple loop to show you what I mean. The first thing we need is a simple integer, like condition. We call it condition because it's the condition to break up the program. We set it to 0, and then to create the loop we need a very specific wording, namely while. While is required to create a program which just runs on and on and on until this thing in the brackets here says that it shouldn't be finished anymore. Again, for a while loop we need these other brackets too, but for the moment we will say while condition is smaller than 10. Okay? Now console.writeLine condition. The following program just shows the numbers from 0 to 9. And as soon as we press 1, you can see 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. It seems like it doesn't work, but we just forgot one simple thing. A while loop runs until the condition isn't fulfilled anymore. For the moment, this condition here is totally true. We are saying that as long as the condition is true, this should be running. And the condition doesn't increase because we only have a gigantic amount of zeros. We don't increase anyhow the value. What we can do is just use an increment for condition. So we need condition and say plus plus. The condition plus plus increases the value of condition always by 1 as soon as it is activated. And as you can see, we are getting the following result, 1, 2. There is a little bug with console.writeLine. Technically you can write console.writeLine and it should be gone. As you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Yeah. This is what happens usually. However, if you forget that the condition can't be fulfilled, then it can be that the whole program just breaks down. Programmers, they are a little bit advantageous because it doesn't break down. But let's analyze the code for the moment. At first we have the int number, the value of 0. Then we have the while. A while condition is only is here fulfilled. The condition is smaller than 10 because 0 is smaller than 10. Then let's open the brackets. Then let's go to condition. Condition increases by 1. That's why we don't see a 0. The condition increases by 1. Then console.writeLine condition. We also can technically do it like this. Then it starts with 0 to 9. As soon as we are finished, we should be able to see what it does. Here we have 0 to 9. Now let's analyze the code again. We start here with console.writeLine condition. Console.writeLine condition is the thing that shows the number here. The first number is 0. Then it increases the condition by 1. So here in the first case we have 0. Then it increases the condition by 1. Then we get 1. Then it starts again at the beginning of the while loop. Okay, the condition is 1. Condition increases. It starts at the beginning of the while loop. Is the condition fulfilled? 2 is smaller than 10. Yes. Then do the loop. We increase it then to 3, and so on and so forth until we get to 9. 9 is condition. Condition is smaller than 10. Okay. Then console.writeLine condition. That's correct. And then condition plus plus. This increases to 10. Now condition is equal to 10, which means it isn't smaller than 10. This means that the loop is finished. We can show it by just writing console.writeLine loop finished. As you can see, as soon as the loop is finished, it works like this, just quite simply. This is the first part of showing you how to create loops. There's a specific program which you can create this way too. Instead of condition, however, we don't write condition. We write a decimal number, and we all change these conditions to decimal numbers. And here two condition. So what we are going to create now is a simple binary calculator, which transforms your decimal number into a binary number. Therefore, we need a string binary number, because binary numbers are interestingly not representable by code most of the time. That's why we are using a so-called string. A string is a simple word, and we can use this simple word to create the code which just does exactly this thing we are going to need. So what we need now is we change the while loop. Decimal number is bigger than 0. Then we need to make sure that the decimal number is smaller, is always reducing. To get the binary number from a decimal number, we always need to divide it by 2, and we need the residue value to create the specific binary value. So what we need now is we have decimal number, let's say 30, yep, or let's say 39. Then binary number, and then what we need to do is decimal number. Is binary number equals decimal number. No, one moment. Binary number plus decimal number. And here in this case we need to put it into brackets, and this percent sign is the operator for modulo. It represents the rest value you can have. So we have binary number equals binary number plus decimal number divided by 2. Then we can do, now we need to divide it, which means we need to divide the decimal number equals decimal number by 2. However, there's also the possibility to write it down like this. Decimal number divided equals 2. And here also it's the same. Binary number plus equals decimal number divided by 2, modulo 2. So the last thing we are going to need now is just, we need to write a line where you write down the binary number. And if we press 1, you see there is a little error which I made. Okay, 1413. This is also a problem that can happen to you if you're using variables. They are case sensitive. That means the decimal number with a small n is different to a decimal number with a big N. Okay, now we have the calculation. It is 111001. The binary number is actually 100110 in the case of 38. I'll show it in the case of 8. Here you can see it's 0001, but this is technically 1. However, if we invert it and start from right to left, then we get 1000. And to get the decimal value out of the binary value, we need to set the position. This is the third position. So 2 to the power of 3 is 8. This is 8 plus 0 plus 0 plus 0. For your information, this first position is the position 0, and this fourth position is the position 3. This is why we get 8 out of this binary calculator. Technically, there should be a little method to turn around the string into turning around backwards. But for the moment, we keep it like this because we are going to do this a little bit later, working with strings and working with other variables. So Now the last thing I am going to show you is another variant of a loop. It's the so-called for loop. A while loop is just so simply created. However, everything with simplicity has also this little problem that it can be much more complicated as soon as you have made a simple error. For instance, if we forget to say decimal number divided by 2, then the program just runs on indefinitely. Let's try it again. Let's try it once. And then press 1. And now nothing happens because he will never get out of the loop. Now let's press 1 again. Here it's the same case, but now it has the possibility to get out of the loop. And yeah, for this there are the interesting for loops. For are the similar loops to usually normal loops. However, in this case, we need to declare something more than just one single condition. At first, we need a variable. We call it int I. I is for increment, usually used for counting up. Int I equals 0, semicolon. I is smaller than 10, and then I plus plus. Now, what the for loop does is I write console white line at first, and then I. What the for loop does is it starts with a specific value. Here, in this case, it's I. Then this second part is the condition, and then this third part is what it should do at the beginning or at the end of the loop. So, in this case, at the beginning, as you can see, it starts with 0. Oh no, at the end, pardon me. As you can see, it starts with 0, then it goes to 1, and then it goes to 2, then it goes to 3. And here in this case, we can just see that it works like a breeze. For loops are something which I prefer to use compared to the usual while declaration, because the for loops are much easier to handle. If you have a while loop, there's the necessity to keep the declaration outside of the loop. And as you can see, the same thing which is necessary to create here is also necessary to is just represented in one number. What we need is this one, and this one to create a for loop. However, as you can see, it's the same case where we can see it like this. We can also do it the same with decimal number. Let's say decinum equals decimal number. This works, by the way, because it's the same declaration, and the first declaration is here beforehand. So, okay. Now we can just do the same thing here. Just saying I is bigger than 0. For int I is decinum, and then I divided by 2. And it should be represented the same. Oh. Okay, there's a little problem. I equals I divided by 2. Now, the only thing that I've forgotten here is that I write a string about this. So we need bin num equals nothing, and then bin num plus equals I modulo 2. And then we should be able to console.writeLine bin num. And let's see. As you can see, it is working correctly. So yeah, it's quite a nice program. I want you to make sure that you learn both of the loops, because both of them have their specific usage. And I can't wait to see what you can create with your amazing loops, and to see what your programs you're going to make. Your Computer Wunsan.